All right, so our unit 3 is called polynomial functions. And what we're going to be looking at in this unit is some of the rules and strategies to follow to first simplify polynomial expressions and then being able to solve polynomial equations, eventually to get to the end of the unit where we can manipulate and change formulas to solve for different variables. So that's ultimately the goal, is to kind of learn the rules necessary in order to get to the end of the unit where we're going to be given word problems, where we'll have to use different formulas and we'll have to be able to manipulate those formulas to solve for different variables within the formula. All right, so we are starting with simplifying polynomial expressions. All right, so the way I always look at this, as I explained in the review, is just like learning a new language, there's rules to follow. You know, in the English language, there's certain letters that can or can't go together. There's grammar, there's punctuation, there's all sorts of rules. Math, think of it as a language, and think of it as also having a set of rules that must be followed that are permissible, and then things that are not permissible. And we'll look at why. I'll do my best to always explain why that's not possible, because it can always be proven why it can't be. All right, so let's begin our lesson. This is really just a review, and we actually covered a lot of this in our review before the course. All right, so first thing, we are looking at multiplying monomials. And like I said, we have done this in our review before, so I'm going to go through this quite quickly. All right, so here we go. We have 4x squared times y cubed times negative 3x to the 5 times y. Right? It's all multiplication there. So I can shuffle around the order. And what I'm going to do is multiply these coefficients together. Okay? And I'm going to multiply my x variables together. And the way I'm going to do that is by adding their exponents. And then I'll do the same thing with the y's, where I'll also add their exponents. And remember that if you just see the letter y, it has an exponent of 1 above it that is not written. So this ends up equaling negative 12 x to the power of 2 plus 5, y to the power of 3 plus 1, which becomes negative 12 x to the 7 y to the 4. Okay, there's our simplified version of that by multiplying it out. Same thing here, all multiplication straight across. So my game plan here is I'm going to multiply negative 2 times 4. Now I know what you're thinking. You're probably thinking, do we do distributive property and multiply negative 2 times 4, but also times a, and then also times b squared? And you don't, all right? And here's the difference of when you use distributive property and when you just simply multiply the coefficients. If the question was like this, in this situation, you would use distributive property. Now, what's the difference between this and what we have here? Clearly, here we have terms that are being added to each other. Okay, so we're adding terms. Whereas here, everything's being multiplied. Okay, so they're different. And it's a common mistake to think that they're the same, but they're different. And so you really have to distinguish between the difference of the two. All right, so let's go ahead and answer this question here. We end up with negative 8. Now I have a to the power of 1 plus 3, b to the power of 2 plus 1. Okay, negative 8 times a to the power of 4 times b to the power of 3. All right, now here we'll be using distributive property because of our minus sign and our plus sign. Okay, so here we will be using distributive property. So you can see the difference there. So I'm going to multiply 2x times that first term, 2x times the second term, and 2x times the third term to get rid of my brackets and remove all the multiplication that is there. So you end up with 10x cubed minus 6x squared plus 2x. Be careful that this is a minus 6x squared because it's positive 2x times negative 3x. All right, so you end up with minus 6x squared there. Okay. Can we do anything else with this? Can we collect any like terms? No, there are no like terms here, right? Because anytime you're adding and subtracting, you're always looking to see if you can collect like terms at the end. And there are no like terms here, right? We have x cubed, x squared, and an x term. Okay, slightly more complicated because now there is 2 variables here instead of 1 like the previous question. But same thing, we're going to multiply this negative 4a squared b times 2ab squared. And then because of the minus sign, we're going to distribute that negative 4a squared b to also multiply it by negative 7a squared b cubed. So we end up getting negative 4 times 2 is my negative 8. And then a squared times a, which is a to the power of 2 plus 1. B times b squared, which is b to the power of 1 plus 2. All right. And I'll clean that up in the next step. And you can skip, like if you know that a squared times a is a cubed, you don't have to write this step, right? I'm writing it out just to kind of show you where I'm getting everything from, but you don't have to write out this step. Now, negative 4 times negative 7 becomes positive 28 or plus 28. A to the power of 2 plus 2. And then b to the power of 1 plus 3. So we end up with negative 8a cubed b cubed plus 28 a to the 4 b to the 4. Can you get like terms? Well, in order to have like terms, each of these has to be the exact same variables and exponents. Well, they're the same variables, but they're different exponents. So no, we cannot collect any like terms. So we are going to box that answer. Next, again, another review is to expand out a binomial times a binomial. Remember, first times first, first times second, second times first, second times second. So you're multiplying everything in the first bracket by everything in the second bracket. Okay, so we end up getting 2x times 5x is 10x squared. Then 2x times positive 4 is plus 8x. Then positive 3 times 5x is positive 15x or plus 15x. And then positive 3 times positive 4 is plus 12. We can collect like terms here. We see that the 2 middle terms have x's. So we have 10x squared plus 8x plus 15x. So that's plus 23x plus 12. Okay, next. Here we are multiplying binomial times a binomial, and then we have a coefficient out in front. So there's a couple ways we can handle this. We can just do this here and multiply negative 5 times m and then negative 5 times negative 3, but then make sure that we keep a set of brackets because we still have to multiply it by this factor or this set of brackets here. Okay, but the way I like to handle this is I like to keep the negative 5 in front. I find that this minimizes the number of mistakes. And then open a set of brackets and then do my binomial times my binomial and put that answer in my set of brackets. And then I know that I still will have to multiply by this negative 5. Okay, I just find that that reduces the amount of mistakes because I find students will forget when they distribute the negative 5 through the first term, the first factor, they lose their brackets and then they don't realize that it needs to be multiplied by the other set of brackets. So m times 2m is 2m squared. M times positive 1 is plus 1m. Negative 3 times 2m is negative 6m m. And then negative 3 times positive 1 is negative 3. Close your bracket. And now let's collect these like terms before I distribute the negative 5. So let's write 2m squared. Now positive 1 minus 6 is negative 5m minus 3. Distribute the negative 5 now, and you get negative 10m squared plus, right? Negative 5 times negative 5m is positive 25m. And then negative 5 times negative 3 is plus 15. You ask yourself at this point, do you have any more like terms that you can collect? And the answer is, of course, that there isn't. Okay, let's move on to a word problem here. So we have a couple of word problems, and you'll see that they're not overly difficult, but you do need to know the formulas for these word problems. Okay, so it says determine a simplified expression for the area of the trapezoid. Okay, so the first thing we need to know is what is the formula for the area of a trapezoid, right? Because we have to use these expressions now within my formula. So if you were to Google the area of a trapezoid, you would get the following formula. Bracket a plus b divided by 2 times the height, where this is your a and this is your b. And those are interchangeable, right? You can assign either one a or b. It doesn't matter. And then here is your h, your height. So all we're doing is we're substituting in those expressions into that formula. And then we're going to look at how to clean it up and simplify it. So let's begin that the area is equal to, now my a is 4x plus 5. So I'm going to replace a with 4x plus 5. Okay, plus, remember, anytime I'm substituting in for a variable, I put whatever I'm substituting in, I put it in brackets. Okay, make sure you do that. I should have used square brackets at the end there, just not to, so we don't double up on circular brackets, but that's okay. Now, times x plus 3. Okay, so now I've substituted everything in. Okay, I used brackets around everything that I substituted in. And now I analyze what's inside my bracket, and I realize that I can simplify or collect like terms inside my bracket because I have a binomial plus a binomial. And whenever I'm adding, I can just drop those brackets inside there. If I was subtracting, like let's say this was a subtraction sign, I would need to distribute the subtraction sign before dropping my brackets. But because it's addition, nothing will change if I just drop my brackets. So we get 4x plus 4x, which is 8x, plus 5 plus 1, which is 6. Now, we can trim down or simplify 8x plus 6 divided by 2. It's all of 8x plus 6, all of the numerator divided by 2. So I know that 2 goes into 8x and 2 goes into 6. So why not simplify this down and say, well, 8x plus 6 divided by 2 is the same as 4x plus 3. So just divide each term, 8x and 6, by 2. And now what I'm left with is a binomial times a binomial, which I know how to handle. 4x times x is 4x squared. 4x times positive 3 is plus 12x. Then positive 3 times x is plus 3x. And positive 3 times positive 3 is plus 9. Our final expression for the area will be 4x squared, and we can collect like terms, plus 15x plus 9. There's your final expression for the area of this trapezoid. Okay, fully simplified. All right, let's move on to our final question. It says, determine a simplified expression for the surface area and volume of the box. Okay, so we need the formula for surface area, but as well for area. Okay, so let's start with surface area. It's quite the long formula here. Okay, so surface area, this is a rectangular prism. And if you were to look up the formula for rectangular prism, okay, for surface area, you have 2 times L times W plus 2 times L times H plus 2 times W times H. Okay, so you can Google that formula there. All right, so let's call, we can call this our width. It doesn't matter which one you call what. We'll call this our length, and we'll call this our height. Okay? So let's now plug in each of these expressions into my formula. So I have 2 times, remember, anytime you're replacing a letter with an expression, put it in brackets. X plus 4 is my L, times W, which is X plus 8, plus another 2 times L times H, plus another 2 times W times H. All right, so you're just replacing your variables with the expression shown in the diagram. And now you can see there's a whole bunch of, there's 3 different binomial times binomials that we are going to have to do. And then we'll have to distribute the 2 with whatever's left over for each of those brackets. So we're going to end up getting, now I'm going to save some time here and skip a tiny step of collecting like terms once I've multiplied this out. So we have x times 8 is 8x. Or sorry, x times x is x squared, my bad. Plus x times 8, that's positive 8x, right? And then 4 times x, that's positive 4x. So I'm going to end up with plus 12x. So I'm just saving a step there because I did the 8 plus 4x in my head mentally. Okay, and then 4 times 8, which is 32. Plus 2, open another bracket, and now do x times x times, and then x plus 5. X times 5 is positive 5x. 4 times x is positive 4x. You end up with plus 9x plus 20. Plus 2, running out of space. Okay, we end up with 5x plus 8x, so plus 13x. Okay, and then 8 times 5 plus 40. All right, I'm going to go through now and get rid of my brackets by distributing the 2 into all 3 terms, all 3 factors, okay, within this expression. So 2x squared plus 24x plus 64 plus 2x squared plus 18x plus 40 plus 2x squared plus 26x plus another 40. Sorry, plus 80. Okay, now we can collect like terms. We've got rid of all the multiplication. All right, so let's collect. I have a 2x squared plus 2x squared plus 2x squared for a total of 6x squared. Okay, then I have plus 24x plus 18x, that takes me to 42, plus another 26x, okay, that now takes me to plus 68x. Then I've got a positive 64 plus 40, that takes me to 104, okay, plus 80, I'm at plus 184. And there it is. Can't go any further than that. That is my simplified expression for the surface area of this rectangular prism. Okay? So you can see all the rules we're following, right? We can't just add and multiply anything we want here. Just like the English language, like I said in the beginning, there's rules to follow. There's certain things that can be multiplied and certain things that cannot. And then there's certain things that can be added together, such as like terms, and certain terms which are not able to be added together. All right? So it's just incumbent on you to learn these rules, okay? Now let's find the volume, just like the question said. And the volume of a rectangular prism is simply length times width times height. So we are going to take each of these expressions, my length of x plus 4, remember, put them in brackets, my width of x plus 8, and my height of x plus 5. So we have a binomial times another binomial. Don't sweat it, just treat two of these at the same time only. Don't try to tackle all three. So let's just multiply the first two together. Okay. Keep it in a set of brackets because I know I'm then going to have to multiply it by this x plus 5 once I'm done. So keep it in a set of brackets. So we have x times x. Then 4 times x times 8 is positive 8x. And then 4 times x is positive 4x. We end up with positive 12x when you do 8 plus 4. And then 4 times 8 is 32. Okay, now multiply it by x plus 5. And so what you do here now is you multiply x times x squared, x times 12x, x times 32. Then also do 5 times x squared, 5 times 12x, and 5 times 32. Okay, so we end up getting x times x squared is x cubed. X times 12x is positive 12x squared. X times 32 is plus 32x. Then 5 times x squared is positive 5x squared. 5 times 12x is positive 60x. 5 times 32, okay, is 160. Collect like terms. So what do we got here? I've got 12x squareds there, but only a single x cubed, so it's going to stay the way it is. 12x squared plus 5x squared is positive 17x squared. Positive 32x plus 60x is plus 92x. Oh, I forgot to put a plus sign there. And then your plus 160. And there you have your simplified expression for the volume. So once again, a reminder that you just have to learn these rules of what you can multiply, what you can't multiply, what you can add and what you can't add together or subtract together. Remember the rules of your brackets and when to keep the brackets and when you can drop them after you've multiplied factors out, okay? And once you learn these rules and get the hang of it, these questions become very, very, very straightforward. And they're the building blocks for where we're going later in this unit when we rearrange and solve some common formulas that exist in the real world.